again and again and again. This is the code to make z the maximum of two variables. Okay, I hope you guys do vaguely remember this one. Do you guys still remember this algorithm? Okay, we have used this one so many times. By now you guys can probably spell it out and write it out in backwards. All right. Before we used test cases, right? Remember, we use x equals blah, y equals blah blah, and then we trace the algorithm. We look at the outcome. We look at z and say, okay, it works for this case. And we try a few times, and it seems like the algorithm is okay. So this time we'll try to prove that the algorithm is correct without using a single test case. All we're going to do is to use logic to reason it out. And actually we'll conclude that the algorithm is in fact correct. Okay? Do you guys understand what I'm about to do? Okay. So no test cases, no traces whatsoever. Okay? You are told that the precondition of line 1 is true. Can someone remind me again, what does that mean? When I say a precondition is true, what is it saying about the variables? We know nothing, exactly. So in this case, we have 3 variables involved, and we know nothing about those variables. We don't know their exact values. We do not know how they relate to each other. We know nothing, which is great because this means that if I can prove this algorithm is correct with no assumptions whatsoever, that means it's going to work regardless of what x, y, and z you give it. Yep, yes, sir. Question?
No, go on.
Okay, moving on. All right. So the first thing we'll do is to figure out what is pre-2. What do you think? Why do you think pre-2 is important? What do we know for sure before line 2 executes in this case?
The line 1 is true.
Line 1 has to be true, or the condition of line 1 has to be true. So that means x is greater than y has to be true. Okay, now that is significant. This is very important. What about pre-4? Okay, if we are about to execute line 4, what is guaranteed in that case?
X is not 1.
Well, there are 2 ways to do it. I'll just do it step by step. I will use not x is greater than y because it's the negation of the condition of line 1. Okay, now, obviously this is not a very good way of saying it. The better way is to say that x is less than or equal to y. It is also important to point out this is less than or equal to, not a less than with a dash. Okay, so this is a comparison operator, not an assignment operator. Is that okay so far? Because I know these two look kind of similar, and I just want to double check and make sure people understand they are different, completely different things. Okay, so now we have pre-4 and pre-2. Can I derive post-2 in this case? If I follow those steps that I mentioned a little bit earlier, what is the first thing I should do? I evaluate the right-hand side and see if the right-hand side refers to the left-hand side, right? That's step 1. If you look at the assignment statement on line 2, does the right-hand side of the assignment operation refer to the variable on the left-hand side? No, x does not mention x whatsoever. So what do? We go to step 5. What does step 5 do?
Forget it.
It's a forget operation. Very good. Okay. So post-2 is, in this case, okay, if I want to be very complete, okay, so I will go for step 1. The right-hand side of line 2 does not refer to the left-hand side. Go to step 5. I'm just repeating myself here, okay, but when you read the notes, this makes it a lot easier to read because I'm just, following all the steps. So what does step 5 do? Apply the forget operation. So that means in order to derive the post-4, we'll have, forget pre-4, anything that mentions what? Z in this case, right? Now this time it is very important because we have 2 variables on line 2. We have z and then we have x. But what are we forgetting? We are forgetting anything that mentions z and not anything that mentions x. Why is that the case? why can't I keep everything that I know about x? Because x is not the one being changed. It is z that is being changed. So it is very important to remember you have to specify the variable on the left-hand side and to specify which part of the precondition to forget. Okay, if you pick the wrong one, then it won't work. At the same time, what do we know at this point? After line 4 executes, we know x and z become the same thing. Is that okay?
X and Y on line 4.
Oh, line 4, sorry. Okay. So now it is just a matter of expanding forget. What is pre-4? Well, just copy and paste it. Copy, paste, and z equals 4. And in this case, the forget operation really doesn't do anything because the only thing we knew before line 4 is x is less than or equal to y, and we're trying to forget all the components that mentions x. Do we have anything that mentions x? I mean, z? Nope, there's nothing that mentions z, so we get to keep everything. So that means, the post 4 is x is less than or equal to y, and z equals y. Is that making any sense so far?
Yeah.
Okay. What about post 2? Very similar, okay? So for post 2, I'm not going to repeat step 1 and step 5 because it's pretty much the same thing. It is kind of symmetric. So we'll just say we are forgetting from pre-2 anything that mentions z, because on line 2, z is on the left-hand side again. So anything or any component of pre-2 that mentions z, they all need to be forgotten. But we also know that after line 2, z will have the same value as x, so we can put it here. And we just expand it. What is pre-2? Pre-2 is x is greater than y. We just paste it here. And the rest are the same. Well, just like last time, the forget operation is not really very useful in this case because the original condition, pre-2, is only x is greater than y, which has no mentioning whatsoever of z, so there really is nothing to forget. So that means we get to keep all that stuff and just say that x is greater than y and z equals x. Yes?
Why the second, post 2, why the second line you say forget x is greater than y and then z again? We already said to get z on the first line.
That is the mechanical part. The mechanical part is basically trying to identify where is the source of this post condition. It is pre-2. What is, we are trying to forget components that mentions which variable. We're trying to forget components that mention the variable z. So you still have to spell that out and then expand pre-2. Then we figure out, oh, this has nothing that contains z, and then you just copy everything here. But you do have to go through the steps mechanically, just in case pre-2 mentions anything about z. Yep.
I am confused as why are we dealing with line 3 or 4 when line 1 is true?
No, we're dealing with every single case. We are dealing with every single case. Whether I work on post 4 before post 2 does not matter at all. I'm basically saying, if we get to line 4, what are we guaranteed before line 4 executes? If we get to line 2, what is guaranteed before line 2 executes? So this has nothing to do with the order of the then and the else cases. Is that okay?
We're proving the true statement.
We are trying to derive the post condition of the entire thing. We're trying to get to post 5. What can we say once we are done with the line 5? What do we know for sure? Okay, that's where we're getting at. Yeah.
Step 1, I was going to see if you can maybe reword it for me. I'm not really understanding what you mean by the right-hand side of line 2 does not refer.
Okay, the right-hand side of the assignment of line 2.
And what do you mean by that, though?
The right-hand side is whatever is on the right-hand side of the arrow, and then the left-hand side is whatever is on the left-hand side of the arrow.
Okay.
Okay? How's that? I just added, assignment arrow in this case. Because an assignment has two sides, has the right-hand side and the left-hand side. The left-hand side specifies which variable we are changing, and the right-hand side specifies, what is the value that we use to update the left-hand side. Okay. Well, so far it's not too tricky, but the last step, well, I guess it's not tricky either. What do you think is post 5? Well, let's think about it and maybe even draw a picture. Because once we have a picture, it's actually pretty easy to understand. Okay, we have a conditional statement. Okay, this is how we draw a conditional statement. We have operations here and here, and these two branches merge together before they exit. Okay, very typical picture of a conditional statement. We have a question here: x is greater than y. Is it true or is it false? True branch, false branch. Z gets x, Z gets y, and that's it. Okay, this picture represents the algorithm completely. So when you think about the pre and post conditions, it's basically saying, if I ever end up here, okay, what is guaranteed at that point? Well, it's guaranteed that x has to be greater than y, because otherwise I would not be taking this branch. So that's basically our pre-2. Okay? And post-2 is asking, when we get through this tunnel here, what is guaranteed? That is our post-2. Okay? And similarly, we have pre-4 and post-4. Is that okay? Once we have a picture, we actually start to see how these conditions relate to each other. Where is pre-1? Here's our pre-1. When we get in, what do we know? Well, we don't know anything about any variables, but that's fine, not a problem. Okay? Where's post 5? It's right here. This is our post 5. So what do you think is post 5? Well, let's think about it. Okay, I'm standing right here, and I cannot remember anything from before. In other words, when I'm standing here, I do not remember whether I came from this path or I came from this path. Okay, I could have come from either paths. So what can I say about the post condition?
It's either going to be post 2 or post 4.
Post 2 or post 4. Very good. Because when I'm standing here, I know I have to come from either this way or this way. So that means, post 2 or post 4 has to be true. At least one of those two has to be true. In some cases, they can both be true. There's no guarantee that it has to be exclusive. But I know at least one of those two has to be true because I must have gone through one of these two loops these two hoops to get to here. Is that making any sense? Okay. So in that case,
So
we'll just
Z
say
would
that
be equal to x or y.
nope. I will start with that. Okay, exactly what you said, which is absolutely correct. Post 5 is a disjunction of post 2 and post 4. Because I know that I'm either coming here or I'm coming through here. So one of those two conditions has to be true. Now, remember, just because one has to be true does not mean that both cannot be true at the same time. Okay? We simply want to say that at least one has to be true. That's all we are saying. So once we know this, then it is just a matter of expanding post 2 and post 4. And that means, we are taking post 2 here and pasting inside the parentheses, and we are taking post 4 here and pasting inside its own pair of parentheses. Can anyone tell me why I